got the structure of chromatin pictured here in two different forms. We should know or should remember that chromatin consists of something called histone proteins in these little bundles, and it's important to note that histone proteins have a negative charge, and we've also got our DNA. Now DNA is wound around these histone proteins and it has a slight negative charge because of the phosphate group. So our chromatin is made up of DNA wrapped around histone proteins, which are then make up these structures called chromosomes, and on these chromosomes are a number of different genes which give the instructions on how to create certain proteins. Now up the top, the form of chromatin that we see is referred to as heterochromatin. And when our chromatin is in this form, our genes, or the genes found on this particular section of chromatin, are in the off position. So they are switched off and they cannot be accessed and expressed. Down the bottom, this chromatin is in the form of, or the structure we call euchromatin. When chromatin is in this structure, the genes are accessible and are switched on. So how does these two different structures come about? It's as a result of a process called acetylation. Now this, the heterochromatin form is kind of a standard structure of chromatin, and what happens is the positive charges of the histone proteins and the negative charges of the DNA, the phosphate groups on the DNA give it that negative charge. They attract each other, which leads to our histones and DNA being nice and tightly bundled. But what can occur is this process of acetylation can happen, where we see acetyl groups being added to the histones on the chromatin. We'll go and draw an acetyl group on each of these histones, and the reason why these acetyl groups are added is because they actually have a negative charge, much like the DNA. So what the acetyl groups will do is they will neutralize the positive charge of histone proteins, so when the DNA, or the DNA with its negative charge, will actually start to repel from the histone proteins, which leads to this spreading out of the histone proteins and the DNA. They bounce away or repel away from each other, which gives this nice sort of spread to the DNA. So the DNA is pulled apart and becomes more spread out. The beauty of this is it means that this spread out DNA allows RNA polymerase to come in and actually access the genetic information off of these genes, so that then that information can be transcribed and protein synthesis can occur and the proteins on the genes can be expressed. So when acetyl molecules or acetyl groups aren't present, we get heterochromatin, which means histone proteins and DNA are tightly packed, and these genes, this segment of a chromosome, are turned off. Whereas when we have euchromatin, genes are turned on because the addition of acetyl groups means that the DNA becomes more spread out and it is accessible to RNA polymerase. The proteins can be transcribed, and overall those genes are going to be activated.